Hello guys, welcome back to my channel MathsPod. So in this video we are going to solve all the problems in exercise 1.4. Okay, so we have studied in the previous theorems that if a rational number x, which is written in the form of p by q, is terminating, then the denominator q will be in the form of 2 power n into 5 power m. And of course the converse is also true, and if the denominator is not in the form of 2 power n into 5 power m, the rational number is non-terminating and repeating. Okay, so now the question is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So we should not perform the long division, and by just seeing the we need to say that this given rational number is terminating or non-terminating repeating just by seeing the denominator, just by seeing the number or just by saying the denominator, but not performing the actual division. Okay, so the first question is 113 by 3125, right? I'll try to write 3125. It's a prime factorization. 3125 5 5 6 30, 1 will be there, so 12, 5 2s are 10, 5 5s are 25, sorry 5 5 1s are 5, 5 1s are 5, then 5 5s are 25, then 5 again, 5 2s, 5 1s, then 3 3s are 9, 3 4s are 12, 3 5s are 10, 6 7 7s are 21. That's it. This is the prime factorization of 3125. 5 cube into 3 into 7. Here the denominator has 7 and 3. It is not in the form of 2 power n into 5 power m. So it is non-terminating. Okay. See, without performing the actual division only, we are saying whether this is terminating or non-terminating. So I'm just making a into mark over here. This is non-terminating. Okay. Second question, 17 by 8. I'll try to write the denominator in the form of 2 cube. See here, it is in the form of 2 power n into 5 power m, where m is equal to 0. Here 5 power 0 is 1. So denominator is in the form of 2 power n into 5 power m. Therefore, it is terminating. Okay, this is terminating. Then the third question, 64 by 455. 64, you can write it as 8 8 is 64, no? So 2 cube into 2 cube, 2 power 6 by 455. I'll do this here, 5 9s are 45, 5 1s are 5. So 91 we have. 91, I think 13 7s are 91, no? 7 3 is 21, yeah, 13 7s are 91, 7 13. This is the prime factorization. 5 into 7 into 13. So of course this is not in the form of 2 power n into 5 power m. So this is non-terminating and repeating. Non-terminating. Okay, let me remove this thing. Let me rub this thing so that we can solve the rest of the problems. Okay, I am just rubbing all these things. So for any given number, if you can write the denominator q in the form of 2 power n and 2 power n into 5 power m, then our rational number is terminating. And if you cannot write it in the form of 2 power n into 5 power m, our number is non-terminating. Please remember this. Okay, then we have solved. I'll do this 4 here only. 5 I can write it as 5 into 3. 1600 I can write it as 4 square into 10 square, which I can write it again as 5 into 3 by 2 square I can write it, no, 2 power 4 into 10 square, 2 square into 5 square. That is equal to 5 into, sorry, L cancelled out, 1 5 over here, 5 over here, then 3 by 2 power 6 into 5 power 1. It is in the form of 2 power m into 5 power n. So it is terminating. It is terminating. Then 29 by 343. 29 is a prime number. By 343's prime factorization, I am doing it here. 3 ones. Sorry, 3 will not go. So 7 will go, no? 7 4s are 28, 7 9s are 63, 7 7s are 49. Yeah, 7 cube. It is not in the form of 2 power n, 5 power m, so it is non-terminating. Here clearly you can see it is in the form of 2 power n, 5 power m, it is terminating. Here you can clearly see there is an extra number 7 power 5, so this is non-terminating. 6 by 15 I'll do it here. 2 into 3 by 15 I can write it as 5 into 3. 3 gets cancelled, so the simplest form would be 2 by 5. This is in the form of 2 power n, 5 power m. The denominator is in the form of 2 power n into 5 power m, where n is equal to 0. 2 power 0 is 1, so there's no harm in that. So since it is in the form of 2 power n into 5 power m, this is terminating. This is terminating. Okay, then 35 by 50, I'll write it here. 35 by 50, I'll write 35 as 5 into 7 by 5 into this. I can write it as 5 into 10, which is 5 into 5 into 2. 5 gets cancelled, then it is 7 by 5 into 2, which is in the form of 2 power n into 5 power m. So this is terminating. Okay, this is terminating. Then the last question, 77 by 210, I can write it as 7 into 11. By this I can write it as 7 3s are 21 into 5 into 2. Okay, here 7 gets cancelled, but there is an extra 3 here. It is not in the form of 2 power n into 5 power m, so it is not terminating. This is not terminating. So we got 1 2 3 4 5 rational numbers which are terminating. Okay, let's see the next question. Write down the decimal expansion of those rational numbers in question 1 which have terminating decimal expansions. That's why I have marked right and wrong over there. Okay, so what are all the terminating decimal expansions? 2 4 6 8 9. 2 4 6 8 9. So we need to solve 2 4 6 8 and 9. We need to solve these questions. Okay, for second question I'm doing it here. 17 by 8, that is equal to 17 by 8. I'll write it as 2 cube. Then I'll divide and multiply and divide by 5 cube. Okay, then 17 into 125 by, I will have 10 cube over here, which is, I'll multiply here into 70. 7 5s are 35, 7 2s 14, 15 16 17, 7 8 5 2 1 5 7 8 9 10 11 12 11 2 2125 by 10 cube. 2125 by 10 cube, which will be 2.125. This is the terminating decimal expansion. Then we will do fifth question, which is 15 by 1600. So this I will write it as 5 into 3 by 16, 4 square into, I will write it as 10 square, that is equal to 5 into 3 by 4 square is 2 power 4 into 2 square into 5 square. I'll write 10 square as 2 square into 5 square, and 5 gets cancelled. Then it will be 3 by 2 power 6 into 5. I'll divide and multiply with 5 power 5. Then I'll get 3 into 5 power 5 by 10 power 6. Okay. So if you solve this, you'll get some number. You try to do that and let me know in the comment section what is this answer. Okay, then we'll solve the sixth question over here. 23 by 2 cube into 5 square. I'll just multiply and divide with extra 5 just to make the denominator in terms of 10. Okay, 5 3 is 15, 5 2 is 10, 11, 115 by, here I will have 10 cube. Okay, then 0.115. Here we have 10 cube, so I'm taking my decimal before 3 numbers. Okay, 5 6 7 8, 6 by 15. This I can write it as 2 into 3 by 3 into 5, 15. I can write it like this now, 2 by 5, that is equal to 2 by 5. This I'll multiply and divide by 2. Then I'll get 4 by 10, which will be 0.4, which is terminating. Then the last question will be 35 by 50. Okay, this I can write it as 7 into 5 by 5 into 10. Okay, 5 gets cancelled. This is 7 by 10, which is 0.7, which is terminating. Okay, this is so simple. If you want to write the decimal expansion of a terminating rational number, first step that you need to find the prime factorization of numerator and denominator and cancel out the common terms which are in them, and then try to write your denominator in the form of 10 powers so that your division will be easy. Okay, next question. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? Okay, first they are asking, first question is whether the given numbers are rational or not. If they are rational, what would you say about the prime factorization of the number q, which is the denominator? Okay, first question is 43.1234567 Clearly this is a terminating decimal expansion. So if a decimal expansion is terminating or non-terminating repeating, it is a rational number clearly. So it is a rational number. It is a rational number and it is terminating, implies q will be in the form of 2 power n into 5 power m by the theorem. Okay, what that theorem says, if our rational number x is in the form of p by q, and of course if our q is in the form of 2 power n into 5 power m, then our rational number x is terminating. Terminating means it will stop at a point. Here it stopped at this point, at point 9. Okay, then second question is 0.120, 1200, 12000, 12000. If you see this question, this is clearly non-terminating, and it is not repeating also, but our rational numbers are only of two types, whether it's terminating or non-terminating and repeating, but this number is not repeating, so it is not rational number, it is an irrational number. Okay, next question, 43.123456789. So the bar is on all the numbers 1 2 3 4 5 6 7 8 9, which means all these numbers are repeating. So this question is non-terminating, repeating, non-terminating and repeating. Okay, so if our rational number is in the form of non-terminating and repeating, then the denominator q is not in the form of 2 power n into 5 power m. Okay, that's it. I think this is the last question, and with this we have successfully completed the first chapter, real numbers, in your NCERT textbook. Okay, I hope you followed all the videos and you have understood all these things. And yeah, that's it for this video. We'll see you in next video. Until then, bye bye. Take care.